To continue this regional climate change signals, let's move to the other end of the world, to Antarctica. Uh, Main point to make about Antarctica is that it's more complicated. Okay, so here is a map that is showing the glacier accumulation and loss. So when it is this reddish color, there is a loss in meters per year of the glacier extent. There are details about how glaciers work. There is a grounding line, and then there is an equilibrium line where the accumulation and the melt rates are exactly the same. If there is accumulation, the glacier grows. If the glacier is losing mass, then the extent keeps decreasing and keeps retreating if it's flowing down a slope, for example, which is what happens in most places. So these numbers are negative, but you can see these bluish colors here are up to +1 meter per year. That means the glaciers are actually accumulating mass. How does that work? Basically, we have to go back to our basic understanding of the Southern Ocean. We said Southern Ocean is a channel, completely open, and it kind of isolates the continent of Antarctica, right? So it's completely surrounded by the ocean. It's an island. And then you add the other complications of what happens if the ocean warms. If you remember the maps we saw of global warming, we said higher latitudes are warming faster than lower latitudes. We said it's because of ice albedo feedbacks. We will look at this a little bit more carefully. There is a term for it we will come back to. So if the ocean warms, the first thing that happens typically is the atmosphere above also begins to warm, and a warmer atmosphere holds more moisture, which means the flow onto Antarctica can create more snow, especially if there are mountains and the air is running into the mountain. It has to rise, expand, and precipitate. Here it's not rain, it's snowfall because it's pretty cold. So even though snowfall rates are small, a warming ocean can increase the snowfall rates. So these kind of complications make for accumulation of snowfall and glacier mass over some parts of Antarctica. There are incredible number of other details. So if you look at the dome, a mountain on which the glacier is building, so you can go from the ocean. So you have here what we looked at before in terms of Antarctic bottom water, and the Antarctic intermediate water, and so on, that are being pulled up. Between them is the North Atlantic deep water that's being pulled up. So there is heat loss between the ocean and the atmosphere. There is carbon release, which we will not worry here. Let's just focus on the heat loss, because that means evaporation and moistening of the atmosphere and potential snowfall on Antarctica. Right? So there is precipitation in Antarctica, and there are what are called katabatic winds. Basically, when winds come down the mountains or the glacier slopes, they rapidly compress and can get warmer and get low pressure. Lots of things happen. In a place like Boulder, for example, if you park a car and close your windows completely, katabatic winds can come down and create such a large pressure difference that the windows can blow up. Okay, so the other important thing to remember about Antarctica is that many of these glaciers are flowing on to the ocean, which means the glacier becomes shelf ice. Basically, it begins to extend. Ice sheets begin to extend onto the ocean, and there is warm ocean below. So the warm ocean is going to disintegrate the shelf ice that has extended onto the ocean, and the tides move it up and down and make it vulnerable to break and so on. When that happens, the entire glacier can be affected by slipping down, changing its grounding line, or moving past the grounding line, and so on. I'm not getting into too many details, but if you can stare at just these processes here, you can at least try to remember that the water that's coming under the ice shelf is going to make the ice shelf vulnerable to warming, as well as the glacier that's attached to it on the ground on Antarctica. So this is where all the complications come from. So you have iceberg calving happening a lot because of this. There is another term here called polynya, which we didn't talk about before, but it's basically where there's an opening in the ice cover. And remember, ice is a good insulator. And the ocean is warm because it's liquid. It's above 0 degrees or whatever the freezing temperature based on salinity. And if there is an opening, then the atmosphere very quickly begins to extract lots of heat from this opening. So these polynyas, which are basically these openings, can create lots of local ecosystems, local air-sea interactions, local heat exchange, and so on and so forth. And they can be very important, obviously have positive feedbacks because of this exchange, and so on and so forth. Okay? That's what you have to remember about Antarctica. Places where the loss is reaching points of no return based on model estimates. There are uncertainties in these estimates, so I don't want to push it too far, but it doesn't look good. And there are huge ice shelves getting carved off and floating along on the ocean. So warm ocean can melt glacier under the ice shelves, but also can increase snowfall in some places. So that should give you a good sense of just how difficult the problem is that we are dealing with. The cascading impacts of our actions and increases in greenhouse gases are not always easily predictable. So once we understand from the data what's happening, then we go and look at the model and say maybe we missed some process that we didn't represent in the Earth system model that we are using for projections and so on.